Hi, this is Raphael Mudge, the creator of Cobalt Strike. Welcome to Red Team Operations with Cobalt Strike, Part 9, Pivoting. In this lecture, we will talk about pivoting, how to relay traffic, tools, and sessions through a beacon payload. We will start out with port scanning and how to discover targets using port scanning through a beacon session. We will then talk about proxy pivoting. We'll then jump into pivot listeners, which are a way of turning a beacon session into a redirector to receive connections. And we'll talk about SSH sessions, which is Cobalt Strike's model for Unix post-exploitation. And we'll talk about an application layer pivot called browser pivoting. I want to start out this discussion with port scanning. Port scanning is important because this is a reconnaissance technology. This is one way to discover other targets you might want to reach in your target network, targets that are not part of your Active Directory domain. Cobalt Strike does have a port scanner built into Beacon, and it is pretty serviceable. Here's the syntax to use it. When you specify host, you can use CIDR notation, you can use ranges, or just host by themselves, and you can separate multiple groups by commas. Absolutely okay. Same with ports. You can specify a range of ports to scan, and you can specify multiple ranges separated by commas. The discover argument is the method to check if the host is alive. If you specify ARP, that will have the port scan tool try to look up the MAC address of the target before it starts to scan it. ICMP will use an ICMP ping to check if the host is alive, or none will skip this entire process and scan the ports for each possible target as if it is alive. Max is the maximum number of sockets open at once. And it's kind of funny, right? It shows you the age of the tool set when I have to say something about Windows XP. But if you are on a Windows XP or 2003 target, do not use a value higher than 4. Your port scanning will be very spotty. It will fail. You can use 1024 or more for Windows 7 and later. That's absolutely okay. Let's take a look at port scanning and working with the targets part of Cobalt Strike's data model. To see the targets in Cobalt Strike's data model, go to View, Targets. Right now, you can see we don't know very much. We know about our foothold, workstation 1, at 10.10.10.191. And if we right-click, go to Services, we don't know about any services. One way to populate this model is to port scan. And that's what we're going to do now. Let's right-click, go to Explore, Port Scan, and this will open up the port scan dialog. And when our beacon checks in, we will get a list of networks that the target system resides on. Let's highlight this network, choose a discovery method, and press scan. And when our beacon checks in, the port scan tool is now off and running. And it looks like our port scan is now complete. We could scroll through the console and look in the output to see if we can find what we're looking for, or we can go to the Targets tab and see what was found by our port scan tool. And that's not too bad of a haul. Let's highlight all this information, right-click, go to Services, and here are the services we found. And you can sort by address if you like, sort by port, and that's how that tool works. A couple things I do want to point out because we're talking about target management. You can add a target manually. You can import an Nmap file or a flat list of IP addresses. And you can also add notes to these hosts as well. For example, we could say this is on the domain corp. You can change the icon associated with each host by changing its operating system. For example, let's go to Host Operating System, set this to Firewall, just to give that a little bit of a visual cue. And you can also assign colors to your targets as well. For example, if we come over here to Host Color, we'll give this a dark blue, which I tend to use to mean ignore this. And we can use green to draw attention to something. And that's what it looks like to change the colors around. So that's managing the targets view. I would like to set up the next demo, and to do that, we're going to need to lateral over to another host and scan that network as well. So let's do that real quick. Let's interact with our beacon, and let's switch this to the targets view. And we're going to jump over to the PowerDC 10.10.10.50. So let me make a token for the domain administrator account. And let's use the jump command with the PSExec64 module to jump over to the PowerDC system. And we will use our SMB beacon payload. And just give that a moment to succeed. When I was actually testing this out, my lateral movement was failing because the hard drive on the VM was full, which took a few minutes to troubleshoot. You know, sometimes things fail for reasons you're like, what happened here? But it looks like we're good. And you can see we got back a different internal address. That's why we have two PowerDCs. And we get back a different internal address because the system is on two networks. You'll see that in a moment because we're going to go right-click on that host, go to System, Explore, Port Scan, and when Beacon checks in, we can see the two networks, and we want to scan the other network. We'll do an ICMP ping to discover targets, hit Scan, and away we go. And our second scan is done. And here you can see we've discovered a few systems in the 192.168.58 network. And that's going to be useful to us a little bit later. A couple things I do want to point out. You'll notice that the icon represents the operating system. I kind of alluded to that when we switched this one to be a firewall. But let me point something out. If you see a white Windows icon, that is a Windows 2000 era system. A flat blue icon like that is Windows 2003 XP era. A little bit more detailed is Windows 7, and the modern logo is Windows 8 and later. So that gives you just a little bit of a hint as to what kind of Windows system you're really looking at. Let me explain proxy pivoting real quick. We have a target system that is compromised, and we have our Cobalt Strike team server over here. And the target is communicating with us via HTTP, HTTPS, DNS, external C2, or even chained through multiple sessions. It doesn't really matter. And let's say we have an application on our system as the attacker, and we want to use that application to communicate with some sort of service inside of the target network. And I'm going to call this target 2. The idea behind proxy pivoting is that we open up an interface on our team server, and our application can connect to that interface, which generates a connect event within the compromised target, which creates a connection to the desired host and port, and traffic between the application over here and the second target are relayed through your Beacon C2 channel. That's proxy pivoting. When you're using your Beacon communication path as a proxy to relay traffic into your target network, it is important that your beacon is checking in as often as possible. The delay between each beacon check-in will introduce latency in your proxy pivoting traffic. To make your beacon session interactive, use the sleep 0 command in the beacon console. This will ask beacon to check in several times each second, giving you the best performance when you are doing proxy pivoting. One form of proxy pivoting is SOCKS pivoting. SOCKS is a standard for an internet proxy server, and Cobalt Strike happens to have a SOCKS 4A server built into its team server. And a SOCKS-aware application can communicate with this proxy server and have any of its traffic relayed through your various beacon chains to reach whatever target you want. Here's how to set up a SOCKS proxy server on your team server associated with a specific session. Interact with your beacon, type SOCKS, and specify a port. Your team server will open up that port, and any proxy traffic that comes through that port will get tunneled and relayed through the current beacon session. And to stop the SOCKS proxy server, use SOCKS stop in the beacon console. After a while, it will become kind of confusing keeping track of all these different proxy pivots. If you go to View Proxy Pivots, you can see which sessions have proxy servers enabled, which port they're bound to, and you have the option to stop them right there as well. The Metasploit framework is an example of a SOCKS-aware application, and you can tunnel Metasploit framework traffic through a Cobalt Strike beacon session with SOCKS. Here's the syntax to do it. Set G proxies, SOCKS4: the IP address of your team server, the port, and set G reverse allow proxy to true. Set G in the Metasploit framework means set global. It is a sticky option that will apply to each module you launch afterwards. And to unset these options, use unset G. I'd now like to demonstrate proxy pivoting with the Metasploit framework. Here we are in Kali Linux, and I have my foothold on 10.10.10.191, and chained through it, I have an access on 192.168.58.3. Just to show you what that looks like, we'll go over to the pivot graph, and you can see that PowerDC is chained through our Workstation 1 access. Now what I want to do is use a Metasploit framework exploit to compromise 192.168.58.205. That's the billing system right here. And to do that, we're going to pivot through the PowerDC system. So let's right-click System, Interact, and let's stand up a SOCKS proxy server. First, let's do a sleep 0 to make our parentmost beacon check in interactively. And let's do the SOCKS command to stand up a SOCKS proxy server on port 1234. And that should do what we need. Now let's go over to the Metasploit framework console. Let's do MSF console. Actually, let me do something else real quick. MSF DB start to make sure we have the database started. Then MSF console. And just give that a moment. And we have a little bit of a heart. That's really cute. Let's do use exploit Windows SMB MS0867 Net API. And let's set our payload to Windows Meterpreter bind TCP. Let's set our host to 192.168. What was that host? 58.205. And we need to set up the Metasploit framework to tunnel through our PowerDC beacon session. Here's how we do that. Let's go to View, Proxy Pivots, and we can see that we have set up a SOCKS 4A proxy on port 1234 associated with this session, right? Press tunnel, and this will give us back a one-liner that we can paste into the Metasploit framework to tunnel our modules through this SOCKS proxy server. So let's paste that. And let's do show options. This looks okay to me. Let's do exploit-J. And away we go. And here you can see Meterpreter session 1 opened. Let's do sessions-I1, sysinfo. And you can see we have compromised the Windows 2000 billing system with the Metasploit framework. So that is an example of tunneling a Metasploit framework exploit through a beacon proxy pivot. Let's say that you have an application that you want to push through a SOCKS proxy, but it is not proxy aware. Well, you can use Proxy Chains in this case. Proxy Chains is installed on Kali Linux, but there might be a package for Ubuntu or whatever you're operating from. And to use Proxy Chains, open up the etcproxychains.conf in your favorite text editor, go to the bottom, and point it to your Beacon SOCKS proxy server. Then you can run Proxy Chains, whatever command you want, and any outbound TCP connections that program tries to make will be forced through the proxy configuration in your etcproxychains.conf file. Let's take a look at pushing a program through a proxy pivot with Proxy Chains. Here we are in Kali Linux. And what we're going to do is interact with our Jim Stevens beacon. And we're going to set up a proxy pivot on port 2000. So let's do SOCKS 2000. And let's find something to push through this proxy pivot. We'll go to the targets table, press Control-A, right-click, Services, and let's look for something interesting to log into. It looks like we have a few options with RDP open. Let's jump over to 10.10.10.5, which is our mail server. So here we are in a terminal, and we're going to open up etcproxychains.conf, go to the bottom of the file, and let's update the SOCKS 4 line to point to our team server IP and the port of our proxy pivot SOCKS server. So we'll do port 2000, and 127001 is okay because the team server is running on this local Kali box. Now let's do Proxy Chains, our desktop, and we'll connect to 10.10.10.5. And this is going through our beacon. And here's our RDP session. And we can log in as Corp Administrator. Let's put in the password. And here we are. We are now RDP'd into this server, the mail server. So that's an example of pushing a non-SOCKS aware program through a beacon proxy pivot. You can also set up a reverse port forward within your beacon payload as well. This will make the target listen on that specified port, and any connections that come to that port will be relayed back through your beacon to your team server and onto a host and port that you specify. To set this up, use rport forward, the listen port, the forward host, and forward port. You can also stop reverse port forwarding with the rport forward stop command. When you set up this kind of reverse pivoting, make sure you account for the firewall on the target, because reverse port forwarding does not disable or create exceptions or do anything to the host-based firewall. Now's a good time to talk about pivot listeners. A pivot listener is a way to turn a compromised system into a redirector that can receive connections from a reverse TCP beacon payload. To set up a pivot listener, right-click on your beacon, go to Pivoting, Listener, and here's where you configure all that stuff. One thing to note is that pivot listeners are not a port forward. You are not tunneling traffic through your beacon. And so pivot listeners are very much compatible with having a high sleep time. So asynchronous C2 for pivot listeners is okay. Let's take a look at a pivot listener. Here we are in Kali Linux, and I have my beacon calling back roughly every 10 seconds. I want to demonstrate that pivot listeners definitely work okay with asynchronous C2. We're going to set up a pivot listener on the PowerDC system. And if we go over to the pivot graph, clicking this button here, you can see that the PowerDC system is chained through Jim Stevens. So let's interact, and let's go to pivoting listener, and let's set up our pivot listener. We'll call it pivot PowerDC. And the only payload option is the reverse TCP beacon. The listen host is not a bind address. This is where our payload will call home to. So if you want to put the fully qualified domain name here, you can. If there's a different IP address, you can use that as well. You can set the port, and the session is pre-populated with what we want. Press save. And when the parent checks in, we will have a pivot listener. Now let's do a netstat-nap find string for port 4444 just to verify that the listener is up and running. And again, we're waiting for the parent beacon to check in. And let me try NAO instead. I always get my Linux and Windows netstat command line mixed up. There we go. So we can see that we have a process listening on port 4444, and that is PID 2460. Go figure, that's the PID of our current beacon. So perfect. We have our pivot listener. It's up and running. One last thing I'm going to do, which is a little ham-fisted, but I am going to drop the host firewall. So let's just do netsh ADV firewall, set all profiles, state off. I have typed that a lot in my time. And once that's dropped, we should be good to go. Great. Now let's go after a few targets. Let's do this. Let's go to View, Targets. Let's do Control B to dock this tab to the bottom of Cobalt Strike. By the way, to get rid of that tab, use Control E for empty. So Control E gets rid of it. And if we go to View Targets, again, Control B puts it back. B is in bottom, E is in empty. All right, cool. So let's go after 192.168.58.35 and 58.205. Let's make a token for the domain administrator account for this domain. We'll use the password waza1234bang. And let's verify that we can hit 58.205 on $. And it looks like we're good to go there. Great. So let's do jump psexec, and we'll jump over to engineer, and we will use our pivot beacon. And if all goes well, there we go. We have a session. And you can see how the reverse arrow is showing the direction of the TCP connection. And we're going to jump over to the billing system in the same way. Let's just do our pivot PowerDC listener. And there we go. And there's our pivot graph. We now have these two systems calling home to the PowerDC as a redirector with a reverse TCP beacon. And of course, any tasks or pivoting or anything directed at these systems will travel this chain back to us. So that is a pivot listener in Beacon. SSH sessions are Cobalt Strike's tool for post-exploitation against Unix targets. You may ask, why SSH? It's an agent that is already available on most Unix targets you will come across. This agent supports upload, download, execute, and pivoting. It also supports encrypted communication. Building those primitives in an agent that works across multiple operating systems and architectures could be very, very challenging. This agent is also a bind agent, so conceptually it fits in well with Cobalt Strike's model for TCP beacons, SMB beacons, and now SSH sessions. If you do want something that is custom configured, that you compiled, pushed over, and ran to the target that you can control via SSH, I recommend you take a look at Dropbear SSH. It is a tiny SSH server. You can bake a configuration into it when you compile it, and this can be a very good backdoor to pair with this particular client capability. How do you launch an SSH session? Use the SSH command within your beacon, specify a target and port, and a username and password. You can use SSH key if you happen to have an SSH key that you want to authenticate with. So how do you do post-exploitation via SSH with Cobalt Strike? Here are some of the basics. The shell command will run a command and give you output, very much how Beacon's shell command works. If you want to run a command with sudo, use the sudo command. One warning though, this sudo alias happens to use a flag that is not available in all versions of sudo to pass the password. So it may work on your target, it may not. If you want to change the current folder that commands are run from, use the cd command. And if you want to download and upload files, use upload and download. Similar to Beacon sessions, downloaded files will be available under View Downloads. As much as possible, SSH sessions feel like a stripped down version of Beacon. You can also do SOCKS pivoting through SSH sessions. Do SOCKS whatever port, and that will bind the SOCKS server on your Cobalt Strike team server, and any traffic that comes to that SOCKS server will go through your Beacon chain and out through your SSH session. You can also do reverse port forwards. One thing I want to point out though, your SSH daemon needs to have an option called gateway ports set to yes or client specified for the reverse port forward to bind to something other than localhost. So do be aware of that. If you're using Dropbear, it shouldn't be such a problem. But if you're just authenticating to an SSH daemon with your own credentials, keep this in mind. Here's something that I think is really cool. You can do some cross-session pivoting. SSH sessions can control TCP beacons. Use connect, host, and port to connect to a TCP beacon that is waiting for a connection. You can also create a reverse TCP beacon pivot listener. Right-click on the session, go to Pivoting, Listener, and set that up. Again, very similar to what we talked about with reverse port forwards, this option does not do anything about gateway ports. So if the gateway ports option is not set to yes or client specified, your pivot listener will get bound to localhost, and that won't be that useful. But in situations where that's not a problem, you can turn a compromised Unix target into a redirector for reverse TCP beacon sessions. Let's take a look at SSH pivoting. Here we are in Kali Linux, and we need a target. Let's go to our targets view. And I think 10.10.10.21 will work for our purposes. That is an Ubuntu Linux system. So let's go ahead and jump over to it. Let's go back to our sessions table, right click, interact on Jim Stevens, and let's do SSH 10.10.10.21 with the username user and the password 1234 bang. This will task Beacon to fork and run an SSH client that presents itself as a very stripped down Beacon session to Cobalt Strike. And when we get a session, that will pop up here. And there we are. There's our SSH session. And if we come over to the pivot graph, we can see the same thing. Our SSH session is chained through our Jim Stevens beacon. If we right-click Interact, you can see that we have a very beacon-like interface. We have the shell command to run commands. We have download, upload. We have SOCKS pivoting. And we can influence our parent beacon's sleep time as well. So that's some of the stuff that's present in our SSH sessions. Let's do a PWD just to find out where we currently live. And when our parentmost beacon checks in, it'll pull down this task and execute it and give us back output. So we're in home user. Okay. Let's do this. Let's go to var www, which I think is where the website lives. And let's do an LSAL. And again, when our parent beacon checks in, there's the website material. Now let's say we want to exfiltrate this. Let's go back to our home folder. Let's go to home user. And let's do this. Let's do tar zcvf. And we'll call it site.tgz. And we'll gather up var www. Oops, my bad. I forgot to prefix that with the shell command. There we go. Now that'll task beacon to pass this out to a shell and execute it and give us output back. There we go. Now let's download site.tgz. And when our beacon checks in, it'll start downloading this tarred up website piece by piece. And there we go. There's our download. Now let's go to View, Downloads, and there's our exfiltrated website. So that's how you exfiltrate files from a Unix target via SSH sessions. We do have SOCKS pivoting via SSH sessions. It's no different than what I showed you in this lecture already. We do have the ability to do sudo. Let's try that out. Let's do help sudo. And we'll do sudo password 1234 bang cat etc shadow. And I said it in the slides, but I'll say it again. The sudo command here takes advantage of a flag that is available in some versions of sudo, but it might not be available everywhere. Or I should say it is not available everywhere. So don't be surprised if this particular command fails for you. But it does work in a lot of modern systems. And here's our shadow file output. So that's an example of sudo. I was talking about SOCKS pivoting a moment ago because I was like, hey, cool, you can tunnel stuff through an SSH session. But what I really want to show you is the ability to do some cross-session pivoting. And that is controlling a TCP beacon through an SSH session. So let's go ahead and take a look at what that looks like. Let's export a TCP beacon payload. Attacks packages, Windows executable S. Actually, we need a TCP beacon listener that is not localhost only. So let's set one up. Let's do add, and we will do beacon TCP. And we will call it local TCP pivoting. And we'll stick this on port 6667, save, and there we go. This listener won't do because it's bound to localhost only, but this one's okay for pivoting. All right, good. Now let's do attacks, packages, Windows executable S. And let's generate an executable for our pivoting beacon. And we will do, let's do a service executable. Why not? 64-bit, generate. And we'll call this servicebeacon.exe. Now let's go ahead and upload this to a target. So let's come over to our Jim Stevens beacon, open up the file browser. And let's go over to File Server, $, Windows temp. The file server is our target, by the way. And let's upload our servicebeacon.exe. There we go. Let's jump over here and let's do remote exec. PS exec on the file server. And let's ask it to run C Windows temp, servicebeacon.exe. And we should have a TCP beacon running on the file server now. So let's come over to our SSH session and let's link to it. Let's do connect to, we could do it by IP address. I don't think the NetBIOS name is going to work from Linux, but let's try fileserver.corp.acme.com. Oops, clear. Clear is how we clear the beacon queue when we make a mistake. That's a good command to know. But I actually need to tab complete and get the right port because 4444 is not going to fly here. All right, so now, there we go. We have now tasked our beacon to connect to a TCP beacon, or excuse me, tasked our SSH session to connect to a TCP beacon that is running on the file server. And so that's an example of how you can pivot across different session types, because SSH sessions can control reverse TCP beacons and they can connect to listening TCP beacons as well. So that's a little bit of SSH pivoting. The last type of pivoting I want to cover is an application layer pivot called a browser pivot. Imagine this. You're on a target, you take a screenshot, and you see that the end user is interacting with a web application that is of high value to meeting your objectives. If they are using Internet Explorer, a browser pivot becomes a way for you to use your own browser and relay requests through their browser and have those requests authenticate as that end user. And this, in effect, allows you to silently interact with that website as that user and work to meet your objectives. It is Internet Explorer only, which is a downside, but when you're in a situation where you can use this, it is really, really, really cool. And let me explain how browser pivoting works, because it's kind of cool. So over here we have our compromised target, we have our team server over here, and our compromised target is indeed, as usual, calling back to us over HTTP, HTTPS, something, or even chained through multiple sessions. And our target is using Internet Explorer, put a big IE right there, to communicate with and browse an internal web application. We'll call it int. And however it's done, whether it's cookies or something else, each request the Internet Explorer is making to that web application is authenticated. Okay? The user is interacting with this website. So how does browser pivoting work? Well, let's say over here on the attacker system, I have my web browser, and I want to communicate with this web application, right? Let's say I was to do SOCKS pivoting. What would happen there? We could do it. Well, here's what would happen. Here's what would go down. I'm just finding a good color to use. We would open up a SOCKS server on our Cobalt Strike team server, make our request through that SOCKS server. The request would get relayed to our compromised target, and our request would hit the web application. There's a problem though. we're not authenticated. We don't have the username, password, client SSL certificate, or whatever is needed to authenticate to that web application. So we're not really anywhere. We can't do what the user is currently doing. And that's a problem. So that's the downside of using a proxy pivot. If we do have those credentials, that's fine. That can work for us. But if we don't, we're kind of nowhere. So then what is a browser pivot and why is it different from a SOCKS pivot, which we've been talking about in this lecture? Well, when we stand up a browser pivot, here's what happens. We create an HTTP proxy server on our Cobalt Strike system. Okay? And we inject an agent into the Internet Explorer browser that is currently running. And we make our request to the HTTP proxy server and we say, hey, HTTP proxy server, go get this for me. Go get, we'll say HTTPS int. Okay? And that request right here gets translated into a task for this agent injected into the user's Internet Explorer instance to do. And what that agent will do is it will translate that request into an API call to a library called WinINet, the Windows Internet API. Coincidentally, this is the same library Internet Explorer uses for its web communication. This library is also where Internet Explorer manages authentication. So by living in the same process context and using this library to make a web request, our request gets made and gets populated with any of the cookies or anything else, any of the other credential material for free. And so now when we make this request here, we're authenticated. And we are, as far as that web application is concerned, just another request being made by the currently open Internet Explorer browser. And that is browser pivoting. Let's take a look at browser pivoting. Here we are in Kali Linux with our foothold on WS1 as the user Jim Stevens. Let's interact with this beacon and let's ask it for a screenshot so we can check in on what Jim is up to. And when this beacon phones home, we will get a screenshot. We can see that Jim Stevens is currently using Internet Explorer, and Jim is logged into his company email with Roundcube and his personal email with Yahoo. Okay, interesting. We can take advantage of browser pivoting to access these websites authenticated as Jim Stevens. And that's what I'm going to show you right now. So first things first, we need to set up the browser pivot itself. Let's do a sleep 0 to task our beacon to check in interactively, because a browser pivot is very much tunneling things through our beacon session. And let's set up the browser pivot agent. Let's right click, go to Explore, Browser Pivot. And we need to inject the browser pivot into one of the Internet Explorer child tabs. No big deal. That's one of these with the check mark next to it. Let's bind this to port 9000, press launch, and away we go. So now that our browser pivot proxy server is running on port 9000, we need to point a browser at it. What I recommend you use today is Chromium. I recommend you use Chromium because there is an option that you can use, Ignore Certificate Errors. And what Ignore Certificate Errors will do is allow you to browse to an SSL-enabled website without getting prompted, in some cases, prompts that you can't bypass. So Ignore Certificate Errors makes this feature a lot better to use. You can also use the -- proxy server option on the command line to point Chromium to a specific proxy server. So that's what I'm going to do. Stand up Chromium right now. And here we are. Now, let's go ahead and try to browse to something that Jim is using. Let's go to www.acme.com. And if we go down to webmail login, you will see we are logged into Jim Stevens' email. So that is an example of browser pivoting at its simplest level. And we can use this to write emails to people too. So just sending an email through a browser pivot, kind of cool. Let's take a look at jumping over to yahoo.com so I can show you what it's like to browser pivot when we are in a browser that actually allows us to do things. So let's go over to www.yahoo.com. And you can see we are being told that we're not secure because there are certificate errors. But because of that ignore certificate errors flag, we're still able to get to this website. And by the way, if we click over here, go to certificate, you can see this is the certificate for browser pivoting. All right, let's go ahead and jump over to the webmail just to demonstrate that, hey, I can jump into Jim Stevens' webmail and start clicking around and doing things. And we do not care about customizing the look of our inbox. Let's hit send. And so that's just an example of playing around with a modern web application using browser pivoting. Yes, this is an older technology, but it definitely still works if you happen to have the right browser configuration. So that is browser pivoting. And now we're at the end of the road for our discussion of pivoting. We talked about port scanning. I also took you through proxy pivoting using socks and reverse port forwards. We talked about pivot listeners and Unix post exploitation with SSH sessions. I also showed you browser pivoting. This concludes part 9 of Red Team Operations with Cobalt Strike, pivoting.